In this problem, a rigid plate ABCD is subjected to forces as shown in the figure. This is rigid plate ABCD subjected to forces, and it is asked to compute magnitude, direction and line of action of the resultant of the system with reference to point A. We have to find out the resultant in magnitude, direction and the line of action of the resultant of system with reference to point A, this point A. Now, resolving this 100 kN force horizontally, it will be 100 kN force only directed to positive x-axis. Resolving this 200 kN force into horizontally and vertically, it will be horizontal component will be 200 cos 45 degrees directed to negative x-axis, and vertical component will be 200 sin 45 degrees directed to negative y-axis. Resolving this 100 kN force vertically, it will be 100 kN only directed to negative y-axis. Resolving 200 kN force horizontally and vertically, it will be 200 cos 30 degrees directed to positive x-axis. And resolving this 200 kN force into vertically, it will be 200 sin 30 degrees directed to positive y-axis. Resolving forces horizontally and vertically, summation fx and summation fy. Resolving this 100 kN force horizontally, it will be 100 kN force only. It is directed to positive x-axis, so 100 kN positive. Resolving this 200 kN force horizontally, it will be 200 cos 45 degrees directed to negative x-axis, so 200 cos 45 degrees directed to negative x-axis, so minus. Resolving this 200 kN force vertically, it will be 200 sin 45 degrees directed to negative y-axis, so 200 sin 45 degrees directed to negative y-axis, so minus 200 sin 45 degrees. Resolving this 100 kN force vertically, it will be 100 minus 100 kN. It is directed to negative y-axis, minus 100 kN. Resolving this 200 kN force horizontally, it will be 200 cos 30 degrees directed to positive x-axis, so 200 cos 30 degrees directed to positive x-axis, so plus. Resolving this 200 kN force vertically, it will be 200 sin 30 degrees. It is directed to positive y-axis, so 200 sin 30 degrees directed to positive y-axis, so plus. Calculating all this, we get summation fx value. Calculating all this, we get summation fy value. The resultant is given by summation square root of summation fx square plus summation fy square. Substituting for summation fx value and summation fy value, we get resultant, and resultant direction is given by theta equal to tan inverse of summation fy by summation fx. Summation fy, substituting summation fy value and summation fx value, we get theta value. Presenting the resultant in direction and magnitude. So what we have is summation fx value and summation fy value and r and theta value. So based on summation fx and summation fy value, summation fx and summation fy value both are positive. So summation fx is 131.78 kN and summation fy is it's 241.42 kilonewtons. So it is in fourth quadrant. Resultant is given by 275.04 newtons kilonewtons, making angle of 61.37 degrees. Now, where the resultant is actually located, we don't know. For that, we have to take moment of all the force components about point A. Now, taking moment of 100 kilonewton force about point A. So, this is 100 kilonewton force, and this will be line of action of the force. This 100 kilonewton force will move along this line of action of force like this. So, and it will rotate about point A like this. So, this 100 kilonewton force will rotate about point A clockwise. So, 100 kilonewton meters, 100 to this 1 meter, making perpendicular distance 1 meter. So, this moment will be 100 kilonewton meters. Now, taking moment of this 200 cos 45 and this 200 sin 45 degrees about point A. So, this is line of action of force 200 cos 45 degrees. It will move like this, move along line of action of force about point A. Perpendicular distance will be 1 meters, and this force component will rotate like this anti-clockwise. So 200 cos 45 degrees into 1 minus 200 sin cos 45 degrees into 1 minus, as it is rotating anti-clockwise. Now, this vertical component 200 sin 45 degrees, its line of action is passing through point A. So it will move along the line of action of force like this. So it is passing through point A. So there is no perpendicular distance. So perpendicular distance is 0. 200 sin 45 degrees into perpendicular distance 0. So moment of this force component is 0. Similarly, taking moment of this 100 kilonewton force about point A, and this is line of action of this force, it is on the line of action, it is on the point A only. So there is no perpendicular distance, so it is no perpendicular distance, its moment will be 0. Now, taking moment of these two components about point A. So this is line of action of force for this 200 cos 30 degree component, horizontal component. It will move along line of action of force like this. So it is passing through point A. So perpendicular distance of this component about point A is 0. So 200 cos 30 degrees into 0 equal to 0 kilonewton meters. Now, for this force component, vertical component, line of action of force is like this. It will be like this. So it will rotate about point A like this, anti-clockwise, and its perpendicular distance will be 1 meters. So 200 sin 30 degrees into 1, 200 sin 30 degrees into 1, and it is rotating anti-clockwise. So it will be minus. So we get minus 100 kilonewton meters, and it removing minus we get 100 newton meters, kilonewton meters, and it is acting rotating anti-clockwise. What we have done is we found moments. Now we found summation fx values, summation fy values, and moment values. Now we have to find out this perpendicular distance from point A, that is given by d equal to summation ma by r. Substituting summation ma value and r value, we get perpendicular distance 0.514 meters, and x-intercept is given by summation ma by summation fy. So summation ma divided by summation fy value, we get x-intercept as 0.585 meters. Y-intercept is given by summation ma by summation fx. So substituting for summation fx value, we get y-intercept, and resultant is given by summation square root of resultant we have calculated already. So what we got is that this is the resultant of 275.04 kilonewtons, making angle of 61.37 degrees to the horizontal. Please note that resultant will make always angle with respect to horizontal, and what we got is x-intercept and y-intercept. So we have x-intercept and y-intercept and angle and magnitude of the resultant. So x-intercept, y-intercept, magnitude and angle, direction.